to the Scala programming language. Scala is going to be the language of this class. So we are going to have a lot of our lecturing through Scala. Sorry, I'm adjusting my, it's behind my shirt, and that might be the reason why I'm muffled. All right, so we are going to learn a little bit about Scala. So the place you have to go for this is the notebook I have posted on Moodle, on Canvas, which is Introduction to Scala. And I have posted like a brief tour through Scala, and it's your job to go through that notebook for week 1, all right? And that's going to be super important. So I'm not going to walk through everything. I'm just going to give you the highlights. And part of the way this will work is as we progress through this course, I'm going to reveal more and more interesting features in Scala. All right, the rest of it I'm not going to touch. So there are certain parts of Scala I'm going to intentionally skip, but those are parts which you would pick up in like less than an hour. There's not much there is left to pick up. What am I going to skip? I'm actually going to skip everything about loops in Scala. I'm not going to tell you about while loops and for loops. And you would be like, what kind of programming are we going to do if we cannot do loops? Well, we're going to do functional programming. So part of it is we will try and avoid loops in Scala. All right, so let me start with Scala, okay? So the first thing in Scala is a language that's very much closely linked to Java. It was designed by this person called Martin Odersky, who is in a university called EPFL in Switzerland. And he designed this language. It's a multi-purpose programming language. It serves a lot of purposes, but it's a functional programming language. Okay, so Scala is meant to support functional programming, number 1. Number 2, Scala is very tightly integrated into JVM. What's JVM? Anyone? What's a JVM? Yeah.
Java virtual machine.
Yeah, a Java virtual machine. Wow, how did that get picked up? Nice. Very nice. So a JVM is a Java virtual machine, right? So what it is it runs a sequence of low-level instructions called bytecode, right? So there is assembly language, which is really, really low level. It's like stuff that's running on your processor. And bytecode is very high level. It's still low level from a programming language perspective, so you will have add instructions and subtract instructions. But you will also have in bytecode objects and function calls, stuff you don't have in assembly language. So it's somewhere between your high-level programming language and your low-level assembly language runs this bytecode. And what the JVM does is in real time, it translates bytecode and executes bytecode. Scala compiles to JVM bytecode, which means that any program written in Scala is compiled to bytecode. Or in real time, it gets interpreted into bytecode, and the bytecode executes on the JVM. So this has one big advantage. Anything that's written in Scala can now talk to stuff written in Java, and vice versa, modulo some conventions you have to respect. So what you get then is anything written in Java. So you can have projects where parts of the projects are written in Java, which is a very popular, widely used programming language. And parts can be written in Scala because certain things are very easily done in Scala, as you will see in this class. So, which means that they can interoperate very nicely with each other. Yeah?
Someone in chat asked, is Scala dynamic?
Okay, so it depends. Scala is, so what is a dynamic language? It's not a very well-defined term. A dynamic language is the language where you interpret that language in runtime. Like Perl, Python, JavaScript are considered dynamic languages, all right? In that sense, Scala can be dynamic. Scala supports interpreters, okay? And that's what we are going to use in a Jupyter notebook sense. But that's not how you are meant to use Scala. That's just like you can run small snippets of Scala code, you can see what they do, you can run some useful scripts, and you can learn the language. And that's what we are going to do it for. But real Scala is compiled down to bytecode. So you have a build process like a makefile kind of a thing. It's called Scala build tools. That's what we are going to use. You compile it down into bytecode and you execute that bytecode, just like a C, C++, Java program. So in that sense, it's compiled. All right, and that's how people will use it, and that's how it's being used in the industry. In this class, though, whenever you do your assignment, whenever you run a Jupyter notebook, you're using it as if it's a dynamic language, and that's supported to some extent. It's not going to be performant, but who cares, right? You're not learning to high performance code in one shot. You first learn how to code, then you learn how to do high performance code, right? So is that okay? That answers the person's question, I hope. So Scala is very widely used in the industry. It's been picking up a lot, and some people say it's reached a steady state. There are other languages that have taken over, but the general theme of functional programming is on the up and up. When I was a PhD student, the only kind of people who bothered with functional programming were graduate students and professors and a few diehard industry enthusiasts who had drunk the Kool-Aid and were converted and had seen the light and decided they were not going to waste the rest of this one lifetime on earth doing anything but functional programming. Okay, and that includes me. But then when I landed into the industry, they said, we do stuff in C++, so you do stuff in C++, or else ... So then I discovered C++ also supports a lot of functional features. So, you start learning that, and because I know functional programming from other languages, I was able to do some very snazzy, elegant functional code that people would send me emails saying, explain this one line of code that you wrote where I had to write 15 lines to do the same thing. I was like, functional programming, right? So I don't want to, convert you by force, but you will see some aspects of functional programming, and part of it is we are going to learn functional Scala, not all of Scala. Because Scala also supports your regular imperative programming. With that, let me start with the first concept in Scala. So in Scala, you can write declarations. So the simplest declaration you can write, and by the way, open up a notebook and type these things out if you want, try them out, ask me questions as I'm going along. This is going to be slightly tutorial style, no other way to teach a language. All right, so I have two things here, a var and a val. Okay, so there are two ways of declaring variables or identifiers in Scala. You can declare an identifier as a val, or you can declare an identifier as a var. Is that good? I haven't told you what kind of identifier is it, right? So in C++ or C, you should have written int x equals 10. I didn't need to tell you that this was an int, okay? So Scala is forgiving that way because Scala has something called type inference. I don't need to tell the type of everything if it's obvious. So it is obvious that 10 is an integer. I don't need to tell the type. Part of this class is you're going to get to situations where you're going to write stuff that type is not going to be obvious even to the Scala compiler. So you tell what the type should be. And if you need to tell, this is how you tell. You put a colon and you write down the type. In Scala, types are all capital letters. So int is capital I, double is capital D, string is capital S, and so on. Good so far? So therefore, you cannot name an identifier or a variable with a capital letter because Scala convention is capital letters are types, small things beginning in small letters are identifiers. So you can say val x colon 10, you can say var y colon 10. So in C++, a val is a const. So what does that mean? When you declare something as a val, you are not allowed to reassign its value. So if you say x equals 11, Scala is going to complain. So let me run each cell. Wait a minute, what happened here? Let's see. Okay, // is a C++ comment. It's not a Scala comment. Okay, // cannot be used. Okay, I just wrote a project in C++ over the summer, so I'm going to get confused for like 1 or 2 days before I get back into Scala mode. Okay, so what happens if you try to reassign a val? It doesn't work. You cannot reassign a val. A val is a fixed value. Its value cannot be changed in the program. Okay, a var, on the other hand, can be reassigned. You can assign it to 12, you can assign it to 13, you can print 14, 15, 16. You get the concept, very simple concept. Vals cannot be reassigned. vars can be reassigned. So which one do you think we are going to use in this class exclusively? Which one would you use in C++? How many of you have ever written a const int declaration in C or C++? A few, right? But most of your program is not going to be constants, right? Most of the variables in your program are not going to be constants because they're going to change. That's why you declare them. That's why you use them. In this class, because we are going to do functional programming, we are going to use var very, very sparingly. In fact, there are certain assignments where if I catch you using a var, you won't get credit for that problem. Okay, so the question is, how do we do it, right? If you can declare stuff but you can't change their values, what are we talking about? So that's where functional programming comes in. We're going to teach you a little bit of that style of programming. So simple concept, val immutable, var mutable. Now you can do stuff like this, right? So you can assign x to 10, you can assign y to x plus 10, you can assign z to x minus y plus 10, you can assign w to x times y minus z divided by 15. So you can add, subtract, multiply, divide, just like you can normally do in any other programming language, using much of the same operators. Good so far? But did you notice something? Like in C++ or C, you can declare something like int x and leave it at that. And that's called uninitialized. In Scala, you're not allowed to do that. Anytime you declare something, it better get a starting value. Okay, this uninitialized business in C, C++ has gotten programmers into so much trouble because certain compilers will initialize everything to 0. Certain compilers will not guarantee you that. And depending on which compiler you're using, you would get different behaviors for the same program because the programmer did not initialize a variable and was just using it uninitialized, assuming it will be 0, whereas it wasn't 0. Okay, it's a standard pain point. In Scala, you have to initialize everything. If it's 0, it's 0. If it's a value you don't need, still initialize it. Good. So how do you write Scala code then? Well, we'll write Scala code like this. So I'm going to talk to you about like a simple example of a Scala program. I mentioned I'm not going to teach you much about while loops, but I'm going to just show you while loops just for the first lecture. Later on, we are going to get rid of while loops. We are not allowed to use them. After assignment 1, if I tell you in a particular place you cannot use a loop, you cannot use a loop. If I tell you you cannot use var, you cannot use var. Okay, and it will become second nature to you, but let's take an example. Here is a function, okay, my first function. Let me make it really, really big so everyone can see what it's doing. So what is it doing? Let's interpret it. So this is syntax. So I hope you will learn this syntax. The only way you will learn this syntax is write 2 or 3 functions of your own. You will make some syntax errors. Once you have finished fixing those syntax errors, you will know how functions are written. So how are functions written? Functions are written with a keyword called def, and that's the defining of a function. The name of the function. Open brackets, the arguments to the function. Remember, in Scala, type declarations have to be there for functions, but when you declare the type of x to be an int, you say x colon int, not int x. And int I is capital. Okay, so far? And here is the colon after the function, and that says int. What do you think that means? The return type, right? In C, it would have been at the beginning of the function declaration. In Scala, the type declarations come towards the end. Many languages have this, and Scala is one of those, right? So you put a colon and you put the return type. Often you will get away without putting the return type because Scala will infer it for you, but I will keep putting them in. Later you will see that there are many cases where Scala will just find it out for you. Okay, so what does this code do? So this code says while x is greater than or equal to 0, print x equals x minus 1. Okay, so it's going to keep printing x and until x counts down to 0, and then it's going to stop at return 0. Okay, so far? You could have written this code in Python with suitable change of syntax, or you could have written it in C++. almost as such, right? Almost as is you could have written it in C++. With some changes you could have, the same code works. Okay so far? In your comfort zone? Very good. So what's wrong with this program though? So when I try and run it, it says x equals x minus 1, compilation failed. What's wrong? Excellent. So this x is a val, not a var. So what have we learned? Function parameters are val, not var. You cannot change a function parameter. If you wanted to change a function parameter, what would you do? Suppose you still wanted to write this code, what would you do? How do we fix it? Turn it into a var, you mean? Yeah. Okay, sorry, with all the masks I can't hear properly. Yes, that's right, except this will not work. You cannot do this. That's not allowed. Scala doesn't allow you to call a function parameter a var. That's not allowed. So what you do is
what if you redefined whatever your input x is as a new var inside the function?
Excellent. That's precisely the solution. Thank you. Voice from the sky. So you do that, and then you change all your x into y. Make sure you're just going to print y equals y minus 1, and it runs. Okay, so that's your my first function. Good so far? Question? Excellent. So I was hoping you would ask the question, why do we not have a semicolon after y equals y minus 1? Very simple. Scala does not require semicolons. I just added one semicolon to show you that it's not a crime to put a semicolon. But Scala does not require semicolon if you begin with a new line. So in other words, if you put the two statements on two different lines, you don't need that semicolon. Scala has something called semicolon inference. It infers it for you. Okay, so imagine how difficult it was for me to do C++ programming this summer after doing Scala in the spring for the 3155 class in the spring. Like when I was doing my project in C++, it's like every other line was not compiling because I had forgotten the semicolon. I had so gotten used to semicolon inference, right? But Scala infers it for you. The only reason you would need a semicolon is you insist on putting these two statements in the same line. Then separate them with the semicolons. Otherwise, Scala is not going to figure out that these are two different statements as opposed to the same statement. So if you put things on the same line, then put the semicolon in so that Scala figures it out. This is going to be a bug, right? Compilation failed, and it tells you exactly where it failed. Okay? But if you put that semicolon in there, Scala will happily proceed. This semicolon at the end is redundant because Scala has the curly braces to figure out that you've ended your block. But if you put that semicolon, Scala is not going to be angry or complain to you. It has semicolon inference, so it infers a semicolon for you. Good, very good. So, good. So my first function works. What happens if you run it? Well, it's going to print all the way from 10 down to 0, and it's going to return a 0, what you would expect. No surprises. And because you've done Seaside 1300 and all the courses between that and this, you should be comfortable with small changes in syntax. Everything should be okay. All right. So here's the deal. Like I mentioned, I am not going to, encourage the use of loops and var. So there is a different style of doing the same thing. And the different style is using recursion. So instead of a loop and a var, we are going to learn a style. And this is going to be the topic of the ending part of today's lecture and the beginning part. And Tuesday's lecture is going to go deeper into this. We are going to use recursion instead of loops as the mechanism for looping. So this is the same code written in a different way. So what does it say? This is my first function recursive. It takes an integer x and it returns an integer. And it says if x is less than 0, strictly less than 0, then 0. I haven't put a return here, and I will tell you what's going on with that in a second. All right? Or if x is not less than 0, then print the value of x and call my first function recursive, but on x minus 1. And that's going to recurse all the way down to 0, minus 1, and x. Is that good? So this code does exactly the same thing as a loop, but look, I am not using a var anywhere. I'm using just val, and I'm using recursion to do the job of looping for me. Okay? Very good. So why didn't I put a return? And there could be a return here too. So why didn't I put a return? So
because
one thing,
Scala infers it.
not really. I mean, you could think about it that way, but it's actually more subtle than that. So the reason is in Scala, an if then else statement is not a statement, it's an expression. So when you have you seen this kind of if then else conditional expressions in C++? So let me give you an idea of what I'm talking about. So in C++, you can write code like this. You can say x equals 0, question mark 1, colon 0. So this kind of an expression says, if the value of x is 0, then it's 1, otherwise it's 0. Okay, and these are called conditional expressions. Or in mathematics, you would have seen this. So in mathematics, you would have seen something like this. Let me try and put something up in math, right? So you would say f of x equals 1 if x is less than equal to 0, or 0 if otherwise. You would have seen these definitions, these conditional definitions. If x is less than 0, this function is 0. Otherwise, it's 1. Think of if then else in Scala as conditional expressions. So then what does that mean? The difference is this. This is a conditional expression. If it first looks at x and says, is x less than 0? If x is less than 0, then the value of this entire thing is 0. If x is not less than 0, then the value of the entire thing is the value of whatever is in the else branch. But what's in the else branch? In the else branch, you have a sequence of two things. And the rule for a sequence of statements is it's whatever value the last thing in the sequence gives you is the value of the entire sequence. Okay, so what is the first thing? Print line x. But that's not the last thing. There's one thing after that. So the value of the entire else branch is the value of my first function reg x minus 1. So the whole expression either evaluates to 0 or evaluates to the return value of this. Okay, and you don't need a return. Is that good? So return just gets in the way here. Return is just premature exit from the function. So when I put a return, what that means is get out of the function at this point with the value 0. And in Scala, the implementation under the hood of a return is extremely shady. So because of that, we will try and avoid returns. We will try and write things as conditional expressions. Is that good? Okay, and I'm going to enforce this point. I'm going to come back to this again and again. And as you see more and more code, what you will see is there is, it makes sense to do things this way. Getting out of your comfort zone, right? But good. All right. So here is another example. Okay, so in this example, I'm counting how many occurrences of a character, ch, exist in a string str. So Scala, like any other respectable programming language, has strings. And I want to know how many times does a particular car occur in a string. I mean, you can write this as a 1300 student. Already you could have written this, right? So what do? Well, declare a variable, a var called count, to keep count of how many occurrences I have seen. Find out the size of the string. So in Scala, the way you do it is by calling this function called, this field called size, str.size. This is actually a function, but we don't need to know that. Okay, so you call size for a string. It gives you the size of the string. And then how do I find out about these things? Well, you have an API for strings, and I will show you where it is. If you Google it, you get the API documentation of all string functions that are available to you, and you can use them. All right. So now you see your first for loop. So this is for I ranging from 0 until n. So 0 until n means that you include 0 but exclude n. So it goes up to n minus 1 and stops. Okay? And then you say if the string at the ith position, notice this funny bracket, we don't use square brackets for Scala. Square brackets in Scala are used for something else. We'll see that in a second. We use round brackets to index into strings or arrays or lists. We use round brackets. And you say if the ith character is the same as ch, then count equals count plus 1. All right? And I don't need an else branch here because the else branch is simply count is the same as count. And in fact, whenever there is no else branch, Scala adds an else branch and says else nothing, or this is called unit. Okay, we'll study that a little bit more later. And then after this whole thing is done, what is returned by this entire program? I don't have a return statement, but what do you think is being returned, or what does the program yield to the...
An integer, the number of characters that matched any character in the string.
Excellent. So the return value is count, right? Because remember, this is a sequence of one statement, second statement, a for statement, which in turn has its own body, which is a bunch of statements inside it. And the fourth statement is just count, or the fourth expression is count. So there's like 4 things in sequence. When you have a sequence, it evaluates to whatever the last thing in the sequence is, which in this case is count. Is that good? So when you have a sequence of expressions, one after the other, separated by semicolon, but you don't need semicolon in Scala. Scala will run the expressions in the sequence one by one by one. When it gets to the very last expression, that's the value that goes back to the whoever is interested in the value of the entire thing.
Can you explain less than minus? Does that have some sort of inclusion, exclusion?
No, this less than minus is just an operator. For loops in Scala are actually done differently. Okay, so hold on to this less than minus. So what happens is this: in Scala, this 0 until n is what is called an iterator. If people who are programmed in Python know this, in Python you create something called a range 0n. A range 0n in Python is called an iterator. It's an object which has a function called next, right? Every time you call next, it gives you the next thing in the sequence, and then there is like, does it have a next, or are you done? So it implements 2 functions. So the 0 until n is actually an iterator, okay? It means something. And so this whole for loop is just translated into a function call, okay? And hold on to that thought. This is just like syntax, okay? So this would, in Python, this would have been I in Python. Instead of the in Scala, you just have this backward arrow. It's not less than dash, it's a backward arrow. I mean, you write it as less than dash, but it's an operator. It's a single operator. It's not 2 things. It's just a single thing, less than dash. Okay, and one of the nice things is because you will be using for loops so rarely, you will be using it, but it will be rare. That, you don't have to worry about it just yet. I will show you other alternatives to for loops that are really good. But for loops aren't bad. As you will see, for loops are actually functional. The way for loops are implemented in Scala is functional. It's what's happening is it's an iterator that's being run, and the body is being run again and again with the iterator. When we get to functors, map, reduce, I will talk more about this. But that is going to be 5 or 6 weeks from now. All right? Okay. So, but at least the syntax makes sense for now. I'll post further things about for loop on Piazza, like further curiosities about for loops on Piazza. All right? This is not your C++ for loop, and I'll try and walk you through a little bit for those of you who are curious about iterators. Okay. So this works, of course, if you define a string called hello world and count how many occurrences, you can see how this works. Okay. Now you can also do a recursive version of the same thing, right? How do you recursively count? So how do you write a function like this? Define a recursive count. Okay, how many occurrences? How many occurrences of a string and a character, and this should return a number. How do we do this? Okay, so if you want to approach it recursively, the things that I shouldn't be doing are I shouldn't be accumulating. I shouldn't be creating accumulators. I shouldn't be doing anything like that. What I should be doing is I should be thinking about base case. So whenever you want to define a recursion, you would think about base case. What's a string for which I know the answer immediately? Yeah?
The empty string.
The empty string, right? So you would say if, and there are many ways to check if a string is empty string. You can check if a string is the empty string, or you can check if the string dot size is less than is equal to 0. Either way, if it's the empty string, then obviously there have to be 0 occurrences of anything in that string. Else, the goal with recursion is always to create a smaller version of the same problem and give it back to the same problem. Right? It has to call itself on a smaller string. What's the easiest way to do it? There are many ways to do it. Here is the easiest way to do it. I'll give you the idea. Check the first character of my string. If it's the same as CH, then count how many occurrences are from the second character to the last character in that substring and add 1 to it. On the other hand, if it's not the same as CH, then it's the same as the substring from the second character to the last character. Okay, so this is like peeling off one character and then treating the remainder of the string as a subproblem. So you would do it like this. If the first character is S of 0 is the same as CH, then I would do 1 plus recursive count HMO of the, not the string itself, but I'm going to use a function called substring. How do I know about a function called substring? You go online and you say Scala string API, and you go to you will see now there are lots of official looking documents, and there are lots of nice people who have actually written tutorials on how to use strings in Scala. So if you have the time, you can look at the tutorials, and if you get really good at it, you can just look at the Scala library documentation. It tells you all the functions, and you will see that there is a function called substring. So here is the function we want. So it says a bunch of things. So this is why you need to know the thing a little bit better. I'll go to a more user-friendly documentation for now. I think very good. So this person has been extremely friendly to us. So this person says s.substring of I returns part of the string starting at index I. This is precisely what we need. Remember, index 0 is the very first index of the string. Index 1 is the second character. So when I say string.substring, where am I? Oops, sorry. Excuse me. Wrong notebook. Here. So, So 1 plus recursive count HMO string.substring 1, the same character, else. So this is when the first character of the string is the same character as the one I'm looking for. Then add 1 to the count from the second character to the end, the substring from the second character to the end. Look for that and add 1. Otherwise what? What should I do? Not add 1, add 0. Right? So because the first character doesn't match, so it's just whatever it is from the second character to the end, that's what it is. So you would say recursive count HMO s.substring 1, comma ch. Now this doesn't look that great. I'm not proud of it. So I'm going to call val inner string. And as a good programmer, I'm going to write a comment for my colleague saying get the substring from second character to end. And then I'm just going to use inner string, clean up my work. Either way, I'll post this notebook after the end of this lecture, okay? So you will have all of this, but this is good. And that works. And I'm not using return. If I did use a return, it's no crime. It just changes the meaning of what I want to do, but you can use return. But we are going to write programs without using return because return has some very strange behavior that I did not know about. So I was happily using it until last semester when we had a very learned TA, Sean Meyer, who's a PhD student in our department, does a lot of work in programming languages, compilers and stuff. And he figured out that return in Scala is implemented in such a funky way that some of the code we write will break if we use return. So, so it was eye-opening. So I'm trying not to use return just because, I discovered it does break spectacularly, and then I have no idea what got broken. So, so I'm not using return for now. But if you use it in the type of assignments I'm giving you for week 1, if you accidentally slip up and use a return, no problems. We will try and write code without it as much as we can, and it might become easier for you to see that. But there are a few weeks where if you use a return when you're doing anonymous functions, functors, when you use return, you will find that things will break without explanation. So be careful at the back of your mind when you're using return that there is something funky there. Is this good? I mean, this should be simple, but recursion is not a topic you would have learned a lot. I mean, you probably were discouraged from using recursion previously. And now here I come and I'm encouraging you to use recursion, right? What's up with that? We'll talk about that on Tuesday's lecture. But today we are just going to use recursion. We'll talk about how to make recursion performant on Tuesday's lecture.